Welcome to this introduction to Rust streams. So let's first think about what is a stream and where is its place essentially in the ecosystem of Rust. If we look at the synchronous world, we can say that a stream equals an iterator, because we want to yield the next item and then essentially we block until we process the next item. The stream is the asynchronous variant of the iterator, because we can yield an item, and while it's yielding or waiting for that item, we can perform other work. So I found this online, an article which describes it very well, and I'd like to read it. And that's this thing. In synchronous Rust, the core streaming abstraction is that of an iterator. It provides a way of yielding items in a sequence and blocks in between. Composition is done by passing iterators into the construction of other iterators, allowing us to clump things together without much fanfare. And that's like a beautiful description of what an iterator is, right? So, because first we get an iterator, and then we can do map, and then we can take, and then we can take while, then we can do any, like we can do all kinds of stuff that is normally present in the functional world without the cost, right? And that's amazing, like lazy evaluation and everything that comes with that. Now we would like to do the same, but then in an asynchronous world. And so this series is about Tokio and streams, right? So everything that, let's say the future abstraction of Rust is based on a polling mechanism. That you have to have a runtime essentially that polls different futures. So, but we still want to have the same abstraction. Like we still want to, let's say, iterate over values in a stream and then apply all kinds of filters on it, right? Like take while, filter, zip, map, and other kinds of stuff. So how is this implemented? So in this episode, we're going to implement essentially a byte stream that takes an async reader and converts essentially into a stream. So we have all the advantages of essentially combining all these things together. So we looked at what a future was in a previous episode. And as we can remember, a future has this method to make it work with the runtime. So if we look at the signature, we see that the only difference between a future and a stream is here in the output. And we see here poll self output, and here essentially we see poll option self item. And this is different. And so because we introduced this option, now we have to deal with a sum or a none. And this is essentially the key difference of the implementation. So let's read the documentation. Attempt to pull out the next value of the stream, registering the current task for wake up if the value is not yet available, and returning none if the stream is exhausted. So as a return value, we have the following options. There are several possible return values, each indicating a distinct stream state. So we have poll pending. That means that the stream's next value is not yet ready yet, so it needs to poll again. Ready some value means that the stream successfully produced the value and may produce further values on subsequent poll next calls, right? And then we have poll ready, which means essentially with a none, which means no more values can be produced essentially and should not be invoked again. So this is very important. So now we've seen this, let's now implement a byte stream implementation. So let's look at the different includes we need to include our own stream that takes an async read and converts this essentially to a byte stream iterator. So the stream extensions, we need the file, we need the async read, of course, and everything that needs what we need essentially to make it work essentially on the Tokio runtime, the core abstractions. So let's just zoom in into essentially the implementation. So we have here an item which we are returning will be an unsigned integer of 8, right? So that's like a byte. Then this is the signature we looked at before, and as you can see, we can see the option here. And we reserve here a buffer of 1, and we call the poll read on the buffer. So here we get the different results that's possible from this poll on the read. Is we're going to be like a ready or a pending, and if it's a ready, we will have an OK, yeah, or an error. So essentially this will return a result. And if we have the OK value, then now we start interfacing. Essentially now we're transforming from the async reader to the iterator trait. Now we start returning, if we have a value, we return a sum value, and if we don't have a value, we return a non-value, indicating stop producing. If we encounter an error, we return a non-value, we say stop producing. And if we're pending, we just pass it through, and then let's say the runtime will know, okay, we have to essentially start producing another value. So just to start, we'll just run this thing. So what we're going to do is we'll open the data text file. Now this data text file is very simple. It says streams are wonderful. And essentially then we say, okay, we are going to initiate this byte stream struct, which has the stream trait implemented. And let's iterate over it with the next keyword, right? And then this is a construct which is used a lot in streams. Because of the option return, essentially, we just destructure essentially in a sum key in a sum variant, and if it's none, then essentially the while will fail and it will just continue, and then we just print it to the output. So let's just execute this, and here we see very nice streams are wonderful with an exclamation mark. So exactly as expected. In the next episode, we will dive a bit deeper and start building some simple streams and also use the streamx trait. I hope you enjoyed it.